All right, so I was asked to do a problem, a differential equation, and the problem looks like this. X squared dy dx equals 3x squared minus xy. And they were nice enough to tell us to use the substitution that v is equal to y over x. So that clue tells us what direction to go in. Without that clue, it might have been tricky to recognize this as a homogeneous differential equation. But the book provides you with this clue. So just sort of follow the logic there, multiply both sides by x. It's not strictly necessary, but then you can use the product rule instead of using the quotient rule, which is a little bit easier in general. So we go f prime g plus f times g prime. And this gives us a substitution for dy dx. So I also notice that dy dx in my original problem is multiplied by x squared. So I'm going to divide by x squared on both sides of the problem. This technically means you're assuming that x does not equal 0. That was also an implicit assumption when you saw v equals y over x. So I'm not making a new assumption that the book didn't suggest to me. I'm just making the same assumption that x is not equal to 0. So now we get dy dx equals 3 minus y over x. So the 3x squared over x squared, and then the xy over x squared. And this is how you could maybe recognize that it's a homogeneous differential equation, because your derivative is equal to a function of y over x. And that's why this substitution for the letter v is helpful, because you have v in your differential equation. You also want to make the substitution that dy dx is equal to dv dx times x plus v. So that's equal to 3 minus v. So double check that you see why I replaced everything with that. Now, after you make the substitution, it becomes separable. So let's subtract v from both sides. So dv dx times x equals 3 minus 2v. Let's get our v's on the left side and our x's on the right side. So I'm going to divide both sides by 3 minus 2v. I'm also going to divide both sides by x. And I'm going to multiply both sides by dx. So I'm doing three things in one. We'll get down here in this corner now. So we have dv over 3 minus 2v equals, I guess it's dx over x. So yeah, x's cancel, dx's cancel, those cancel. So everything looks good. The left side is just a natural log antiderivative. If you want to do a quick u substitution, you can see if u equals 3 minus 2v, then du is negative 2 dv. So that's going to give me negative 1/2 natural log of 3 minus 2v. And over here, I just have natural log of x plus c. I guess I should straighten those out to be absolute value bars. I'm not given any initial condition, so I guess I can't really assume if either one of them is positive or negative. I'm going to multiply everything by negative 2. So absolute natural log absolute value 3 minus 2v, negative 2 natural log absolute value x. Just keep it plus c because it's still just an unknown constant. Okay, let's create a little bit of space. I'll go to the top left corner to finish it out. So then I'm going to raise both sides, exponentiate both sides. So now we have absolute value 3 minus 2v equals, remember when you've got e to the c, you can just make that a c in front, just like when I multiply by negative 2. I could raise it to the e, and then I have e to the negative 2 natural log of absolute value of x. A couple things I'm going to do here. Negative 2 in front of a natural log can be a power on the input. Absolute value is either equal to positive or negative. So the c value, again, can absorb both sides of the absolute value. So I have 3 minus 2v equals c. E to the natural log cancels out. So I have absolute value of x to the negative 2. So then I can isolate v. So I'm going to subtract 3. And we're almost done. I'm going to bring the absolute value of x down below the c. Absolute value of x squared minus 3. One nice thing I'm noticing now is that if you square the absolute value, you're going to get the same answer as if you square just x by itself. So it doesn't matter if x was positive or negative because you're squaring it anyway. So that's kind of a nice thing. I can actually get rid of that absolute value. And I can divide by negative 2. So I have v equals c over negative 2x squared plus 3 over 2. And then recall at the very beginning we said v is equal to y over x. So I'm just going to make that v into y over x and then multiply both sides by x to get y equals c over negative 2x, just canceling one of the x's there, plus 3 over 2x. And that's the solution. So then, allegedly, now, if you take its derivative and multiply its derivative by x squared, you should get back to the original differential equation. And I encourage you to try that out. It's not always super obvious. Oops, come on. It's not always super obvious how to get back to the original differential equation. So here it is written out for you again. X squared dy dx equals 3x squared minus xy. But I hope you can see how if you did take the derivative and multiply it by x squared, you can see some of those pieces showing up. And it's a good exercise for you to try to make it work. So let me know if you've got questions or comments, and I will help out.